Okay, so welcome again to the webinar. So basically today we wanted to talk about big data and the role of big data in our technologies today. So basically the webinar has been powered by Marshall School of IT in collaboration with Jenga eLearning and also Jenga AI. So basically, my name is Erick Otieno. I am one of the instructors at Marshall School of IT, where we offer several courses to do with data science, data analytics, cybersecurity, software development, Internet of Things, and we also offer some master classes in emerging technology. So as Marshall, we came up with an e-learning platform that we called Jenga e-learning. So if you want to get the link, you'll always find it here at elearning.marshall.co.ke. So if you are in this platform, basically you can find some very interactive courses to do with data, cybersecurity, and software development. So to dwell much on Jenga e-learning is that it is actually an e-learning platform where you can actually interact with video lessons that are pre-recorded, and also you can find one-to-one instructor consultation. So also with Jenga e-learning, we also given you an opportunity for you to do some quizzes and assignment so that you can test your skills with real-time assessment. And also we have career and mentorship. So recently we introduced Jenga AI, which is actually an AI-powered personalized learning, which focuses on adapting to your progress and understanding. So this tool actually can give you some AI-generated lessons, auto-suggested videos, and audio tailored for your learning practice. So all these links, I was actually opening them up. So this is the link to our Jenga e-learning platform. This is actually the link to learning today. So basically, our main agenda today was about giving knowledge to do with big data and how big data is effective to our industries today. And with that one, I wanted us to introduce our guest today, Mr. Simon. So Mr. Simon has extensive knowledge in several areas in IT. And basically today, Mr. Simon wants to talk about big data and the role of big data in several applications today. So basically now you can start.
Okay, thank you, Eric, for the warm introduction. I think I'll just jump straight into my presentation. I think I'll just share my screen, share this one. I hope you're able to see my screen. Yeah, so my name is Ngeru Simon. I'm a software engineer, big data enthusiast. I'm also an Internet of Things developer with a keen interest in the future of data, which is now narrowing down to AI, machine learning, and that's the direction we are taking. And today I have some slides prepared here just to help you understand exactly what big data is, way beyond what the jargon, there's a lot of fear being spread around big data and what it means, what it entails, and exactly how do we leverage this big data to be able to run the different sectors we are in, maybe our specific domains. And I think I'll just take a look of it and look back in history, the evolution of data, where we're coming from and now where we are headed to. So the whole essence is to have a scenario where you're able to get your decisions be it business objectives, be it personal objectives that are, aligned and informed by the data that preceded whatever event is happening. So come to think of it, is like a hotel owner who knows how many donuts will be bought tomorrow. So he's well prepared on how many, gets to prepare for what will sell and what will not sell. So it's getting ready for the future based on the patterns established in the past. And I think just also to mention is that we have an estimate that 90% of the world data actually right now has been generated in the last 2 years. So let's have a dive into it. And what is big data? So this is the main challenge and rather the main question, and what this is what we'll be talking about, and our conversation will be rotating in and around this for the next, 30 or so minutes. So we are looking at large, complex data sets that the traditional infrastructure will not be able to handle efficiently. So looking at it, we have a whole set of structured data, unstructured data, and also some, semi-structured data. And when we mean by structured, we are looking at maybe spreadsheets, what you type in right there, your SQL databases. We are looking at semi-structured data that's around key pair values for those in tech. Also looking at unstructured photos, all these social media posts and whatnot. All of them are, part of what we refer to unstructured data. And an analogy of now getting to understand big data is a big is like an overflowing library where the books arrive faster than how you can organize them. So you're looking at a scenario where we're having data streaming in at a very high velocity, and that's actually what we look next on the characteristics of big data, so that we understand what is classified as big data, what is classified as just the typical or rather traditional data. And by that we look at the 5 V's of big data. So number one, we look at the volume. That we're looking at how big is the data. So by definition, also literally, big would mean like, big chunks and whatnot. So volume would mean it's a huge, enormous volume of data. So volume has to be big. Then we're looking at the velocity. Velocity is at what speed is this data being generated? At what speed is this data being, brought into the picture, and at what speed is it being saved? So that's when it comes to now velocity as a characteristic of big data. Then we're looking at variety. Like I mentioned, there are different formats involved here when it comes to like running big data. We have structured data, we have unstructured and semi-structured, like I mentioned earlier. Then we look at another two. Actually, the last two concepts are very interesting because they came in as additions. That's the veracity, that's the accuracy and trustworthiness of the data. Because it's not enough, again, to have big data. It's not enough to have any other data if it's not accurate and it's not trustworthy. So that means if we are to get any insights from data, then if it is to be valuable, then that means the accuracy and the trustworthiness of the data should be okay. So that's the aspect of veracity. Then the value comes in extracting useful insights. Otherwise, as we'll see later, there's actually very high cost involved in terms of infrastructure, of storage and processing. That's in the data still and the data in movement. So looking at those costs and whatnot, you'll see again, we have to derive value from this data. Otherwise, there's no essence of, keeping all this data and having it all. And remember, the main essence of any data and the main essence of keeping all these data is to uncover any patterns. Because again, collecting data is not enough. You may have a scenario where maybe the government wants to expand road X and, and there's a road Y. So how do they tell which one is, more frequently used than the other one? So we may as well get to know like how many vehicles pass a minute, how many vehicles pass every hour. And from that, you're able to again tell other factors coming into play. What are the socioeconomic activities affected by road A over road B? So it's just a question of data, and we are trying to minimize as much assumptions. So we are going to deal now with data and whatnot. So let's have a difference of the big data of now what is so-called traditional data. So look at it from 3 facets. That's the volume, processing, and the tools. So those 3 facets will give us, like a differentiating factor. So traditional data, in essence, is small, say a data for an institution, and we have records of, these are our students and whatnot. Then when we look at big data, we have data coming in from, sensors sending data every now and then. We have those counters that tend to, update every 10 minutes, every whatever period. So we're looking at, huge data. Then traditional data was normally structured. So that's why we saw the rise of Excel. And actually, Excel is still a very good tool, used up to date, and solves out of a lot of business questions and whatnot. So, but mainly deals with structured data. Could be CSV files and maybe normal Excel sheets, and that's the typical definition of structured data. It's there. This is how it was fed into an Excel sheet and how it works. Then looking at big data, we are coming into now handling both structured, unstructured, and semi-structured. Again, those three terms are commonly used here. Then we look at the tools used around traditional data. We have Excel, SQL. This is for those who are, in tech and whatnot. We have now on the other side, we have SQL, Hadoop, Spark. The rise of NoSQL, that's the likes of MongoDB, because again, not all data actually has relationship. So some of them, are actually running on NoSQL. And also looking at big data and the traditional data, there are a few items that we need to take note in terms of the development. What are the enablers of this transition, or rather this shift of paradigm from traditional data to now big data? So we're looking at the advent of digital storage. That's the rise of digital records keeping, electrical record keeping. We've seen the rise of cloud computing actually, which has also impacted so well. That's now in terms of providing scalable solutions. So you look at scalable solutions that you pay for actually what you use, and you can actually even get more than you anticipated. So should your data grow, then means the storage grows with the data. So you've seen also the industry applications of AI, machine learning, and whatnot. So those are some of the differences that came in and are being now in discussion. And on to the next one, then we see over these characteristics and whatnot. Why does big data matter? That's a question. And looking at this is that at the end of the day, the essence of data, besides keeping records of your clientele, know your customer and whatnot, there is a whole aspect of getting to know what segment of this clientele will be ready to absorb this new product. What segment of this clientele is not satisfied with our product? It's about getting to understand your business and minimizing, again, a number of assumptions. Like we said earlier, the goal is to minimize assumptions by improving the decision-making process, so that should you have this decision, it was a causal effect of this data that you had, and you arrived at a decision based on what information you had. And again, like we said earlier also, it's about establishing patterns. So if you own a hotel and you keep the data for over a month, and you realize on Tuesday, that's when you make the most sales. So you might realize over time, they tend to shift. So as they shift, you also have, an idea of how to adjust, your staff accordingly, how to improve on specific sales and whatnot. So that's what we're looking. And looking at also the real world examples, for instance, Netflix recommendations. So you watch movie A, which is an action movie characterized by maybe a certain actor, and you have a tendency of having maybe you like someone's movies. So what happens with AI, and now this whole aspect of this data that is being collected, is that they're able to recommend a movie for you. Then based on the selection, they know we have a 90% accuracy. The movie was nice. This person watched the movie halfway and whatnot. Looking at it again, also how fraudulent transactions are being flagged actually, even in bank sectors and everywhere, is say for instance, you're used to perhaps doing a transaction of maybe 10,000, if you do at most 11,000, maybe 15,000, and all of a sudden, person X is doing a transaction of 200,000. So it's so easy for you to be called, to go verify the transactions and whatnot. So you're looking at, this big data coming into play by being now analyzed, and after the pattern is established, we're able to tell this person is able to do this person is not able to do this. We also need to confirm if it's indeed this person trying to, run this. So the business impact and everything, and now the larger industry. So we'll still narrow down to, how it rolls and becomes now into use. So you look at how it's collected. And we have a number of sources that's social media or whatever you post outside here, all these data can be harvested and can be profiled, and these tweets are maybe this person is sounding more depressed than they were last week. All these solutions are coming in terms of getting to analyze what have you been doing and what is it that you're doing. And these cases of outliers, this is now a negation from your pattern, or rather a deviation from the norm. Say you used to wake up at 7 a.m., prepare for work, or rather go to the gym at 7:30 and whatnot. If you start waking up at 5, then
So, please.
Yeah, hello. Sorry, I think we lost him. So I think he's back here. Yeah. Okay.
Okay. So sorry about that. I had a slight technical issue. So I'll just proceed on where we were. We were at how it is collected, and we are seeing at how it gets to your application and how it forms, basis of profiling and whatnot. So we're looking at also some ethical considerations around big data collection. Again, while you prepare to go collect data, you need to have some aspects you also put into place as a player in this industry. You need to check into data privacy. Are you intruding into someone's data? Then also you're looking at the security aspect. How are you going to secure this data? Some of this data might have, some personal information, which you may be allowed out of consent by the user to have, but not to share and spread. So as a player in this industry, we are looking at, the ethics around it, yeah? And we just move next to, analysis process. Like I mentioned, collecting data is not enough. We are looking at making sense out of this data. And number one process is the objective setting. And the objective setting is actually the question at hand. The question at hand is, for instance, you might have a question. I'll just go to my previous analogy. Which road is to be prioritized, based on the resources? Do we have to improve on road A or road B? So that's a question. So the objective is to determine which road will be prioritized. That's now our objective setting. That's a question that we have in mind. The next thing now is to get into the information gathering. Information gathering will be basically from our data set, the data that we have. Not everything is useful for each question. So this is where we come into question of which are the variables of interest. Is it the number of cars? Is it the number of traders that seem to masquerade a certain area? Then from there, we're able to sort all this data. Then we clean it. After cleaning, that means from this data, you'll see what is called dirty data and clean data. So dirty data comes in as a result of maybe some missed fields. The same way, like if someone did a survey, you realize some fields were not filled. Other fields actually, it was they were optional. So one could fill or not, or maybe it was an issue, someone typed wrongly and such. So we look into the aspect of cleaning data And then again, doing the actual analysis, which now means you're doing an analysis from some sort of clean data. And later on, you have now to share the results. So the whole concept of now reporting is what falls under now results sharing. So these are the stakeholders you have to report back from the objective. So it will be basically the process of forming an answer from your data. So you have the objective, you gather the information, you sort it, you clean it, analyze it, then share back. That's reporting. And any question, or rather any analysis, will fall under either of these 4 categories. Number 1, we have descriptive analysis, which was now tries to describe or rather determine what has previously occurred. So descriptive analysis is a sort of analysis that tries to explain. For instance, there was an accident along Ngong Road. We are trying to understand why did the accident happen. So we look at how are the traffic lights at the time and all that. So you try to gather all this data, and now you try to describe now that event. So that's a descriptive analysis. Then we look at diagnostic analysis. Then we look at diagnostic, which is a consideration of figuring out why. So the question of why is like, is it the road overclogged, or why the situation happened? Given that there was this description, why did it happen? Then we have another one called predictive analysis. Predictive analysis is trying to establish future patterns based on previous data. So for instance, you may want to know like, there will be an event. Say we have the Safari Rally event. How has the turn-up been in the last three or so occurrences? And how has the sale of, say, mandazi chapati been? Now from that sale, you're trying to like, come up with your future readiness if you are intending to invest in the next Safari Rally that is going to happen maybe in the next few weeks. So that's predictive analysis. Then we also look at another aspect of prescriptive analysis that helps you to create future suggestions. That's now a prescription based now on, all these previous data. You can prescribe to someone, and you can be able to address some of these issues in and around like any other questions that may fall under a prescriptive analysis call. And with that, we look at the tools and technologies in big data. These are now like now the infrastructure and software enablers of all this. Stream behind it. I think, okay, there was a slight lag, but I think it's fine now. So tools, we have the processing bit of this data. We have the likes of Hadoop, Spark. We are looking also at the storage. We are looking at data lakes, data warehouses that we later discuss. We are looking at the analytics bit of it, and we're also looking at the visualization bit of it, and how they're emerging. And looking at it closely, you can, there's also another term that is quite common nowadays called ETLs. You might have heard of it, ETL and data flows. You'll hear people mention about pipelines. So the whole concept behind all this is extraction of data, that's from their sources, transformation of this data, that's what we talked about now, trying to, clean it, have some mess sorted out a little and whatnot, then loading this data. So the whole concept about ETLs, data pipelines and whatnot is getting all this data from different sources. So you have data coming in from IoTs and server, and just trying to forming them to a manner that will fit into the description of what you have as a data storage, and now up to the last element of loading them for storage. And some of these tools, actually, we'll discuss them and see if maybe you can just have a preview of, just a highlight of exactly what it means and how they flow like. So these are now the enablers. And looking at the emerging issues right down there, we have the rise of serverless computing, real-time analytics, and these are some of the things that are coming in now to improve and now forming a challenge on the existing infrastructure. And some of these questions will be based now on the emerging trends. They will come to solve them. And right next, we just look at some of the use cases. Like now, for instance, in healthcare sector. Healthcare sector, we've seen nowadays AI-assisted diagnosis. We've seen also like for TB, diagnosis. Easily you can, be taken a photo that will be analyzed by a machine actually, and be able to tell like this person could be in the eligibility criteria of someone who could be suffering from TB and all those. So we're looking at those diagnoses that are coming in. And also we've seen the rise of, telemedicine and whatnot. All this is presented by, the rise of big data, looking at finance, fraud detection, risk assessment. Risk assessment actually is the same thing that they actually use even when it comes to, loan determinations, for instance. If they need to know like what's your loan limit and whatnot, and this person X who is trying to ask a loan maybe on a given platform, they check, let us access your M-Pesa messages, let's have a look at, your bank statement. So basically they're just trying to run through your historical data and tell exactly from your history, this data that we have about this person, what kind of a person are we dealing with? Is it a slippery person? Is it someone who is, bound to pay, not bound to pay? Look at retail. And this is where we have all these retailers and whatnot coming in, and we have all these recommendations, supply chain optimization. This is where we say, like, where demand is coming in, which item is going, which item is likely not to go, given a certain, population and whatnot. We've seen lifestyle recommendations. We've seen also traffic prediction actually coming in, and like there are also like the Uber surge pricing. We've seen, all these items are coming in, being enabled, trying to, as much based on your patterns and what has been there and what is likely to happen in future. So basically bridging that gap of what may happen based on, what happened. So it's actually the whole paradigm we are discussing, and is the whole concept we are talking about. And now let's look at the career and opportunities around big data. So we've seen we have data analysts. These are people who entirely deal with, trying to analyze all this data, make sense out of, derive correlations between, items and whatnot. Those are the analysts. Data engineers are coming in. We talked about ETLs. There are people who now purely focus on, flow of data from one point to the other, bringing the data together and making sure like, it's finally housed somewhere. So those are the data engineers. That's a path also one can choose. We have data scientists. Data scientists will focus more on, more of predictive than the analytical, than the, light analytical bit of it. Is where we try to, formulate models, make, draw some, some scientific models out of, this data, and, have the correlation between each model, and, tend to work around the format. Yeah. Then we have BI analysts. These are people who now focus on maybe trying to tell the business, like from this angle, this is where we are headed in terms of profit wise and whatnot. And are we able to, like, how will you be sustainable in the near future? Is the business likely to fall? Is the business likely to make profits? How is it doing? And this is mainly actually used in even in insurance. Actually, insurance, they've been using this. Even underwriters and whatnot tend to rely so much on the BI data, because how much are we spending on paying people and such. So business applications that are around here that actually are formed by behind the scenes is the big data, is the customer insights for marketing. This is what we've seen when we have all these, say you Googled Techno Y9 and such, then the next minute you have a lot of, ads around it. These ads are a result of whatever was shared as a customer. This is a potential customer for a Techno Y7. So this data is processed behind the scenes, and all these recommender systems coming in now from the advertiser side, they're able to tell, like, this is someone who can potentially buy this. This is someone who can potentially buy a phone. This is someone who can potentially buy this type of car. And now all this information is what now is derived by the big data. We are looking at operational efficiency. We've seen, like, from the predictive, the higher the accuracy, then we're able to have, better operations in terms of what we stock, what we don't stock, and also product development. This is as a result of what feedback are we getting given a certain, platform. For instance, we have a platform, the Jenga eLearning, for instance. So there's so much data around, like, how do you feel about it? How do you do what? And now from this information, it is so easy for one to move from one point to the other and develop some other product that would actually be, a larger item of what we had, and that is more informed based on the user's experience. So we're looking at product development. And remember, anyone can, start and build them. So it doesn't matter your career path, actually. And you'll see when we are looking at the trends in big data, you'll see the rise of no code and less code applications. So that means like there is no more that big scare of people being behind black screens and being called techies and being able to run. And now you are there, maybe from a different sector, you're a teacher, you're a policeman, you've not been a tech savvy for the longest. So you'll see some of these tools, and actually most of them are, AI enabled, and we just get to, understand. So I just need to, just show like where to start. And on this slide is in a nutshell, this is just a highlight. Like if you want to start now with big data and whatnot, you can start small, actually. It's allowed. And this is where we are looking at maybe probably just a focus on structured data. Are you able to derive insights from maybe a given even Excel sheet of students? Are you able to tell, like, can you be able to rank them, maybe form some bars and whatnot? So if we're looking at big data now in in the larger picture, we are looking at learning programming. That means Python, SQL, R. Those are mainly the language. And this doesn't mean like they're exclusively the languages around them. No, we have so many others, just like based on, what's commonly in our, within us, what most people are actually absorbing. So Python has been very vital for the longest. But then we have SQL to deal with structured data. Then from there, we're looking at familiarizing with cloud platforms, because you remember we said all this data has to be stored somewhere. So the rise of AWS, Azure, Google Cloud, and they are very nice, interesting products. So just familiarization. You don't have to know actually everything. It's just a bit of, so that you're able to, not refer to again, what's called AI-assisted programming so much. You have the concept, you know what to do. You just need to, gather some maybe nitty-gritties and also maybe help you debug. And, at the end of the day, you just need to be somewhere, just 30% there, 40% as you improve. The more you practice, the more you improve. Then from there, we're looking at experimenting with the tools. We have Power BI for Microsoft users. We have Tableau. We've seen Jupyter Notebook coming in. And we've also now seen this other platform, Google Colab also is coming in here. And Google Colab is also like, all these are items where you don't have to, set up a lot of things. I don't know, install what dependencies. And that's actually what we are talking about, no code and less code. We are coming on improving them slowly by slowly, having all those web setup IDs and whatnot. Then we're looking at online courses. Online courses, we have the likes of the main ones are the Coursera, Udacity, YouTube, and now you can see like coming in like the Marshall School of IT. We also have the likes of Moringa and everywhere. So these are like institutions where you can go take a course and be able to perhaps also have some, one-on-one guidance on some areas of improvement, and they're able to get your feedback back and forth and whatnot. So then the other thing is to join the big data communities. We've seen Kaggle, we've seen GitHub, LinkedIn groups. Basically, this is where you can be able to discuss and keep tabs of your progress, as well seeing what other industry players are doing out there, because from the challenges is where we get to, learn more and also get exposed to more information, and that forms most of now the learning. And don't be surprised, don't get stuck, just move pace by pace. Get someone you can actually, ask a few questions. There's a lot of information out here. All those machine learning, playgrounds and whatnot are there. So that's the whole concept of getting started. And we have a few challenges also in the big data, in and around it. We've seen the question of privacy and security, general data protection regulations. We've seen a question of breaches. I don't know which organization is selling whose data. We've seen actually even in recent scenario where people are discussing about SHA and whatnot, where is the data seated? And these are some of the challenges, because we are dealing with, a lot of data. This is patient information, for instance, for the case of SHA. And we can see some of these cases have set precedents now to, what are now now the developments and the regulations around big data. So we're looking at storage and management. That's what we mentioned about scaling. We've seen also the data quality issues, where we say, instead of someone doing their data collection right, they cook the data. So garbage in, garbage out. So that means if you don't have accurate data, then that means whatever insights you'll have drawn at the end of the day won't be accurate. So we have a very keen interest in the data quality. Otherwise, you'll mislead the whole group, but it's a question of the data that you are using. Then we look at the high cost. This is what we're saying, like data retention is actually very expensive. Having to store all these gigabytes, zettabytes of data, it's quite, it's quite cost a fortune. Then also looking at the skilled workforce shortage also, that's the demand for, the next gen technology and the available talent. So there is actually the need for people to upskill. And this is where now we have some of these what are they called? Some of these opportunities coming in. So develop yourself, be good, then you can start small, probably by, just also running some small insights within your office, within your setup, be able to advise people ABCD based on, ABCD, then that's how now the workforce is going to be, get bigger with time. And we have a larger community coming in of big data practitioners. Then let's look at the future of big data. So the future now, we are looking at AI and big data. This is where we are bringing in, better, these predictive models where we're able to tell, like, based on these occurrences and based on this trend, again, it's a question of trend. We can tell in the next 3 weeks, there might be hurricane. In the next 3 weeks, there might be, a surge in, a certain thing. Within the next, from what the symptoms we are seeing, we might need to have some, fever running in, and the readiness of the practitioners and whatnot. That's now the AI big data now in the specific fields. We are looking at edge computing. This is data. We're looking at processing data as closer to the source as possible. So this is now where we look at the cases of even self-driving cars. The decisions have to be made in real time. So we are looking at having the processing within the data source. So that means data doesn't have to be sent to a server for a decision, but rather we'll have everything running within the node. That's the edge computing. We're looking at the big chain and big data. Remember, blockchain is just, blocks of transactions then that are linked together. So with the linking and whatnot, we are forming, the security and trust, because they say it like it's like a digital notebook. So that's the rise of blockchain and big data. Automation and no-code AI. Again, democratizing the data analytics. Right now, you can easily log into Power BI, just coming with a simple data set, just draw an insight or two without even knowing how to code. You don't actually even need to know Python. You don't need to know C programming. You don't need to know Java. It's just, these are the tools that are now coming in to make sure that it's becoming easier by the day how to, work around analytics. And now there's the whole concept of about democratizing it. Then we're looking at also quantum computing. This is now the future breakthroughs of now data processing, because with all this big data, then that tells you we need big computing and big processing power. So that means we'll have the rise of, or rather what's currently running in its early stages now, which now means it's behind the quantum mathematics and quantum science, rotating around quantum, mechanics over, the classical computers. So there is a whole concept of, superposition and entanglement. There are a lot of items within quantum computing, and now those are some of the things that are coming to divide quantum computing. And, initially it was a question of computers and logic being one and zeros. So quantums is doing something in Colab where we are seeing an item can be 1, 0, or both. So that's a whole discussion that's coming in, and people in that field actually are doing so much. Yeah, so these are some of the things we expect to see coming in and running and bringing now the whole future. Then the last, closer to the last one, we're looking at just a small demonstration of maybe what we mean by data collection, storage, cleaning, and something. So I'll just share just something small. You don't have to get everything, just like a concept of, the flow of data from a data source, which is now actually, because I won't use the primary data collection as us at this point. I use secondary data. So we look at data stored at Kaggle. That's now in terms of now the collection and storage. Those will be intertwined. We clean it a little, we visualize it just to see any correlations and just enjoy. So let me reshare one of my other windows. 1 second. Just get something here running. So just 1 second. Share my screen. Just second. Okay, so I'll just be able to share my entire screen. Just show my window here. Okay, I hope everyone can see my screen. Sure. So this is Kaggle. Kaggle is, we mentioned it at one when we were mentioning about the communities. And now it has many data sets, actually. You can come in and practice with a lot of, pre-collected data that has been merged and brought in together. And some of this data is very clean. Other data is not clean. So, and they normally document the data that you're working with. So I'll just look at this. Is a HR analytics job change of data analytics and about the data set. So they normally give a description. So this is not the only data set that they have. They have thousands and thousands of data sets. So this is just somewhere you can start with, just get maybe some data to work around with, work around it, see what results you're getting, improve by the day, and within no time, you're good to go and you're doing good stuff. Then also we have some of this code that people have previously done and submitted on the platform. You can also do and submit. There are some discussions. These are people asking what was done here. So you can see the discussion around it. You can also have another suggestion section. So all this information is out here, is for free. It's just for you to practice, within your knowledge, within your scope, within your pace, get to see where you can start and work around. Then from there, you might be career ready sooner than later. So we'll work with this one. This is the data set we are looking at. Is it imbalanced? Most features are categorical. So they normally give the definitions. So I have this notebook. So when we were talking about IDs and whatnot, this is an example of an ID that's basically an ID is an integrated development environment. People who started programming earlier will tell you how they started. You do your code in Notepad, no structure, no nothing. Then you try running it elsewhere. So all these things have now been brought together, and you're able to run, your code within one space. So that's why integrated development environment. So Google Colab is just but one of those examples, and you don't need to set up a lot of stuff. You just need to know what libraries to use. So remember, when we were talking about the learning path, we mentioned about getting to understand Python, for instance. Python is widely used. So this is a case that we used Python just to, work around it, just gather the data, visualize this data, then tell, are there any trends within this data? And this specific one was trying to understand, or rather trying to predict whether an employee will be promoted or not. And, it's just like it. So for those who've been attending the classes on these are basically libraries. So don't be scared about these code for the first timers and whatnot. So you've seen the libraries that you intend to use. You bring them on board. Then from there, you have to prepare your data. So this is the data we are getting from Kaggle, and this is the actual, these are now the links that we are going to derive it, and these are the actual data sets. So a CSV is a comma separated values. We have many data formats, just like we have PDFs. CSV is also some, sort of data formats. They are there. So we first install all these, libraries. These are what we intend to use, missing number and whatnot. Most of these things, we'll dig them into details later on. And you prepare your data, you get it. And from there, this is an instance of head. Head basically shows the first 5 records. So we are looking at how the data looks like. Some of these things, basically like the company type here is showing us none. This is where the company type was not inputted. So these are some of the things that we are talking about, cleaning your data, making sure you're working within, given grounds. This is what you have. This is, last new job in the greater than 4 years and whatnot, training hours, you know, all these things are coming in, and you will realize later that not all values again are of interest. So you will see later we are trying to remove some fields that we don't need and whatnot. We are coming here to dig the information about this data, each column, and you know how many are null, what's the data type and whatnot. So all these are now becoming now basis of, you know, what you are talking about, data analysis. And this is part of, you know, understanding the data you're working with. Remember also, as you're trying to, you know, work around these data sets, you need to have like some element of understanding what's going on and what exactly are you trying to, you know, solve from it. So non-unique. So I'll just drive fast and, you know, just highlight it, because I think also for the interest of time, I'll just, we'll share this one later. So this is where we have the different visualization. These are some of the things we are talking about visuals. You see like this visual was formed by, you know, this is a single line of code. And later you realize even in Power BI and other platforms, you actually don't need to know anything about this code. You just get your data, you want a histogram, you want a bar graph, you want a cut plot, what plot you have, they all have. So these are some of the categorical analyses, you see. So we are trying to visualize the data, and from this now, even when you're sending some of these messages to the the strategic directors, for instance, they might not be able to dig into, you know, your CSV files, but with such a graph and such a chart, they're able to tell like, okay, so we have more of blue. What is blue? Then they can see, oh, blue is this, blue is that. You see, so this is what we're talking about now, visualizing your data. This is now correlation matrix formed with a heat map, which basically shows the correlation given columns. What is the relationship between target being achieved and the gender? What is the someone? So he's just trying to, you know, see the stronger the correlation, and so on and so forth. Then we form some charts. Again, this is just all about visualization. Then later on, this is where we have some bits of predictions that we are trying to form. So you'll see people will mention about prediction and everything, and you realize some of these things come later and form some graphs. So basically, it's a question of visualizing this data, understanding it, and also drawing insights. So we're looking at actionable insights within it and whatnot. So that's what I could have done in a nutshell within the time, and just jump back to this one and finish my presentation. And I'll just go through quickly the key takeaways which you've had today. Number one, we've understood that big data is everywhere and is growing rapidly. So that means from what you search online to what you scroll, what you type, what you know, tend to see on your devices, all this data is everywhere and is growing rapidly. Then we've seen also it drives decision-making in businesses, and insights are drawn from, you know, the data we have. Then we've seen also the careers around it. Then we've also seen that learning big data skills can future-proof your career. So that means the sooner you adopt these technologies, the sooner you're able to align yourself with, you know, these current trends, then becomes the better for your career and for yourself in terms of making yourself future-proof and not being taken away by these AI and big data models that will come and, you know, analyze data more better than you can do. So apply as much and be good. And I think lastly here, I'll just ask you guys to ask questions and stay curious. So I'm open for questions. Thank you.
Yes, so thank you so much, Simon, for that very insightful session where we've actually seen what is actually big data, how do you collect big data, how do you process big data, and what are application area of big data. So what has actually interested me about this section is that we can actually see a relationship between what we've been doing in our Python for data science classes, where we learned about Python libraries like NumPy, Pandas, and actually hearing from an expert, it is actually proven that what we are actually learning currently and what is being used in the market. So with that one, I think now we can ask, we can give an opportunity for any question that you have. So any question?
Okay, Francis, I can see your question, and you've mentioned looking to data engineering or big data is starting by learning AWS cloud computing a good choice. So you first need to understand, like we mentioned, big data is not a one career path kind of thing. And with your keen interest in data engineering, I think you'll be more interested in understanding how this data flows from one point to the other and making sure like the data in transit is secure and the quality is not affected on the way. So looking at AWS has a lot of, how do I put it? There's a whole thing about S3 buckets and whatnot. It could be a good choice to understand how the data sits in the cloud, actually. You could look at it, it's a good starting point. I would say there isn't like a perfect starting point. There isn't, again, there's a question of resources within you. The people who start locally trying to build these engines, SQL Server and whatnot. They are good, they're available. AWS is also a good starting point. It's just a question of what you're also comfortable working around. Because remember also some of these tools, because AWS is one of the tools, are also manipulated by the roles that you learned. For instance, whatever I did, and probably the next employment, I'll be, introduced to a whole new, maybe on Azure or maybe another platform. So it's a question of getting the basics right. Go understand how this cloud computing works and whatnot. Then from there, get yourself, an internship or maybe a role somewhere if you're planning to improve on what you have. Then from there, it will determine actually what you will learn next. So it's a good basis, actually. It's a good choice. If you're able to start with AWS, well and good. Then you can proceed with the rest. Yeah, thank you. So thank you, Ryan, for the feedback. Then assuming Martin Onyango. So I think, Franklin, is that well answered? If you have anything, you can follow up there. Then Martin Onyango is asking, assuming that you have a good number of skills in big data, what is the most ideal way of seeking employment opportunity? As it seems that the direct way of applying is not cutting it. Well, Martin, the most ideal way of seeking employment opportunities. Number one, there is a concept of these whole social meetups around, like you've seen events around tech and data. Those are normally very good spaces where you're able to identify people in the industry who are actually perhaps doing something you're interested in. And more often than not, actually, you may land as an assistant to a given project, for instance, and from there you're able to proceed. There are also all these job seeking sites, LinkedIn, whatnot. You can post what you're working on, and you may never know who is actually watching. So there's also the whole concept of bringing now the knowledge to the community. Start by probably influencing a number of people within you and learn to share your skills slowly. Then with the time, you realize that, at times opportunities meet you when you perhaps least expect them. Yeah, so keep applying. That's for a fact. You have to keep applying. And number two, network as much. Number three, use all these job boards and everything. Nowadays it's running online, everything. So there are no overheads so crazy as earlier before, where people used to pay for post office, I don't know what. So apply as much. seek connections, share your knowledge, and within no time, actually, you realize opportunities can be anywhere. Yeah, so that's what I can comment with Martin, and also ask also Eric to comment on the same in terms of opportunities around and probably share where they've used it before to get it. Then we have so I think so Martin, that's well answered. Benson, also yours lies within the same context of Martin. How do I get an internship for data analysis and science? That's good. Again, we've said there is so much knowledge actually coming in and so many platforms coming in. So for you to do the due diligence, try to understand are these actual, you might be somewhere, someone will scam you, your hard work. So also there is a question of, with all this online visibility, you may do also people who do, academic writing and they're able to, perform some of these tasks for other students. So I think yours was preempted on what Martin asked, but also if you have a follow-up question, you can ask. Then we have Mwaniki saying, this is my first day on this platform. Thank you. And this is a good idea. Having done an actuarial science and currently doing CT papers, would you advise me to do R or Python? So again, the path we said, the paths eventually they will collide somewhere. This path will eventually meet somewhere because the basis of data cleaning, the basis of exploratory data analysis and all those, they are the same. So it's a question of finding a language that you're comfortable working with. I would personally vote for Python, but if you are more comfortable working with Python, well and good. If you have someone maybe around you who is able to mentor you in R, well and good. Remember, these concepts are, they rotate in and around the same thing. The processes are the same, the framework is same. So even if the implementation differs, at the end of the day, we'll be able to communicate the same insights from this data. So R, Python, all good. So it's just a question of what you're comfortable with and the resources within you. So S Minor is asking, how possible is it to incorporate the data analytics into existing system like Laravel or Spring Boot system or such? S Minor, I think having collected all this data within your existing system, perhaps you're introducing, maybe, mind you, it's not microservices. Okay, that's fine. I can see where Spring Boot is coming in and Laravel. So perhaps you have this whole reporting aspect of all this data. It's okay. Your system is running on a given platform and whatnot. So we've seen the rise of APIs everywhere. So like now, for instance, if one has done maybe something using Superset that's based on Apache, they're able to integrate with whatever platform, just a question of calling it and it answers. And from there, you're able to proceed. The rise also of Power BI and all these other platforms, because at the end of the day, they've realized if your system is not interoperable with other systems, then you might miss out a lot. So there's a lot of development going in around, for formation of all these incorporations by use of APIs and everything. So that's not a topic of worry. Don't worry about it. As long as your data is seated somewhere, you can use any tool that works so well with you, integrate it with the existing system, and boom, you have your analytics and you're good to go. Then Benson had, do we have a professional body exam for data science and analytics? Do we have CASNEB for accountants? Okay. This again is, we've seen the rise of very many communities and very many bodies. Again, remember, it's about democratizing, data is kind of has tend to be so open. That's why you're also seeing a lot of gaps and gray areas in, regulating big data, AI and whatnot. So at the moment, I think, not sure about it. If you have any particular one that's actually, at the end of the day, is even the rise of CASNEB is by becoming an authority within, accounts and whatnot. So the things are coming in, but as an individual, much focus is on how much you're able to solve and how you proceed. But it's something I would be also be keen to check. But the authorities within it, we are still developing them, I think. Yeah. So that's what I can comment on that, Benson. So I think any other question or someone raising their hand? No, so.
Yes, so thank you there. I can see as Minor, you've raised your hand. I don't know whether you want to unmute and say something. Okay, so thank you for those good questions. Like, this is one that someone had asked whether how do you incorporate data analytics with existing application? Maybe to add on what Mr. Simon has said, there are tools like probably Power BI, where you are also able to link it with several database systems. So you're going to notice that applications actually built on top of a database. Probably it could be MySQL or Oracle. So therefore, there are those tools like Power BI, Tableau Desktop that actually can allow you to connect to a database for a real-time analytics. So with that one, any other question? Okay, so looks like no more questions. So I just want to appreciate you for joining us today. And we'll also be having, actually, there's one more question for you, Mr. Simon from Franklin.
Okay, Mr. Franklin, you've asked, yes, retrieve my chat right away. You've asked the difference between data science and engineering and how to transition from one to the other. And this is it. There's a very actually thin line in terms of how the everyday looks like for both careers, data science and engineering. Data engineering has a major focus on transformation of data and flow of data. That's data engineering. Getting to know like the thousands sources of data. How do we eventually then form a pipeline that will empty towards a data warehouse where it will be seated and housed, and the in and around it. That's where there's a major focus on data engineering. On the other side, data science is more focused on now these analytical and re-engineering of this data to form models. So data science has a more focus on modeling given this data and trying to draw the correlations within them, and all that lies under data science, and the other one is data engineering. So, and how to transition from one to the other. Transitioning is
Before Lady wants to punish Jenga, why hasn't he invoked the same provision?
one simple apps was what have we been doing in engineering? Here. That in order, Franklin, you let me know if it's well answered. Then we have Benson. What is the average pay for data scientists after learning with the Jenga platform? Number one, there is no correlation between where you learn from and the average pay. That's what I'll say. It's all based on, I think what we say is the industry kind of, is the industry which at the moment is quite, things are getting wide and flowing. There's a lot of fluidity around it. So the question of average pay, I may not have the figures with me, because again, but you can check so Glassdoor, they have all these they bring to.
Okay, so thank you for those wonderful questions. So what I would just urge you is to continue practicing your knowledge and skills, because actually Mr. Simon mentioned that one challenge that we are experiencing in the field of big data is the the expertise, the knowledge and expertise. We have limited people.
Yes, maybe
Have,
at local and around it. So